This is for Year 12 Specialists. It comes out of Chapter 6. It is sketching this rational function, which is a cubic divided by a quadratic, and to find all the relevant features. Okay, using some algebra and the fact that I have one term in the denominator, I can rewrite this as all over x squared which will give me 3x plus 4 minus 1 on x squared. And I can treat that as being the linear plus the upside down trunkish. Okay, to find the asymptotes. Well, when this goes to 0, it approaches this straight line. So as x approaches positive infinity, y will approach 3x plus 4. And if this is positive, this whole expression is going to be negative, therefore it's going to be from the below. As x approaches negative infinity, y approaches 3x plus 4. But if this is negative, when it gets squared, it's also going to be negative still. Well, it's going to turn it to positive. Therefore, it's still going to be below. To find, when x approaches 0, we have a problem. Therefore, we're going to have an asymptote at x equals 0 because x can't equal 0. So I'm going to have asymptotes at y equals 3x plus 4 and x equals 0 should be my asymptotes. Since x equals 0 is an asymptote, there are no y-intercepts. To find the x-intercepts, I make f of x equal to 0. Since the denominator can't give me any solution of 0, it's only the numerator. And if I'm looking at the numerator, p of 1 will be 6, that's no good. P of negative 1 will give me minus 3 plus 4 minus 1, that's good. So therefore, if I go 3x cubed plus 4x squared minus 1 divided by x plus 1. So I've completed that division and that gave me a remainder of 0. So I've got x plus 1 and I've got 3x squared plus x minus 1, 3x and x, 1 and 1. I'm not going to get to 1, so I might use the quadratic formula because I know that x equals negative 1 is one solution and x equals minus b. So minus 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 1 all over 6, 2a. So I get x equals minus 1 plus or minus root 13 on 6. So I've got minus 1 and I've got negative 1, 6 plus or minus. So negative 1 plus root 13 on 6, negative 1 minus root 13 on 6 are my three intercepts. Let's find a turning point. So therefore I've got to take the derivative. So I've got 3x plus 4 minus x to the negative 2, and I wish to take the derivative of that. 3 plus 1 on x cubed, no, plus 2 on x cubed. And if I set that equal to 0, I get minus 3 equals 2 on x cubed equals minus 2/3, x equals the negative cubic root of 2/3. So I've got the line of y equals 3x plus 4. And I have the upside down truncus. So what am I thinking? I'm thinking that it's asymptotic down here and it goes through there and it becomes asymptotic up there. Here we have it's asymptotic here, it goes through there, goes up, comes back down and becomes asymptotic again. And that turning point there. So what does the nice clear picture look like? X equals 0 is an asymptote, y equals 3x plus 4 is an asymptote, and my curve looks like that and looks like that, where that is negative 1 plus root 13 on 6, that's negative 1 minus root 13 on 6, that's negative 1, that x coordinate is the negative cubic root of 2/3, and I'm not going to work out the y-intercept of that point. I need a calculator to do that.